Let's look at an example of how we could use generating functions to solve pretty simple recurrence. So let's look at recurrence a sub n equals 2 a sub n minus 1. And this is going to be valid for n greater than or equal to 1. And we're going to have to throw in an initial condition to tell us what happens at n equals 0. So let's say that we have a sub 0 equals 1. Now I bet you could solve this one without generating functions, but I'm just going to show how the technique would work. What I'm going to do is I'm going to try to create a function, f of x. And that is going to be the generating function of this sequence that I have defined recursively. In other words, f of x is going to be the sum for n equals 0 to infinity, a sub n, x to the n. Now, making this definition, what I can do is I can take my initial equation, I can multiply everything by x to the n, and then I can add from n equals 0 to infinity. So now I have a little bit different equation that comes from the initial equation that I had, and now my new equation looks like this. Now what I want to do is I want to make this, small problem, I made a mistake. This says that this is true for n greater than or equal to 1, so this summation bounds should be true for n equal or greater than 1. Okay, that's really important, and be sure that you check that carefully if you're doing this problem. So now what I want to do is I want to take this equation and I want to relate it to the generating function that I've defined. For the f of x, it's pretty close. These are almost exactly the same, except that this side is missing the n equals 0 term. So what I actually have on the left-hand side is equivalent to f of x, except I have to subtract off 1. Okay? Now let's look at the right-hand side. This is almost right. If you look at what this starts out at, this is 2 a sub 0 times x to the 1 plus 2 a sub 1 x squared plus dot dot dot. Well, I can factor out a 2. In fact, why don't I go ahead and factor out an x as well? If I factor out an x, now what I have is this is 2x times a0 x to the 0 plus a1 x to the 1 plus a squared, a sub 2 x squared plus dot dot dot. Well, that's exactly the same thing as 2x times this function f of x that I defined originally. So now what I have is a relationship. I know that whatever this function f of x is, it satisfies f of x minus 1 equals 2x times f of x. And so now my goal is to solve for f of x. But f of x is just a variable, so I can maneuver it around however I need to. So over here, I get f of x minus 2x f of x equals 1. So f of x times 1 minus 2x equals 1, which gives me f of x equals 1 over 1 minus 2x. So I have done it. If I was asked to solve for the generating function, I could say the generating function of this sequence is f of x equals 1 over 1 minus 2x.